In this video, I'd like to continue talking about the geometric series formula when we have finite sums. And in these example problems, we're going to need to use that formula. So before we start looking at the problems, let's start by writing down the formula. So let's say we have a sum with n terms, and this is equal to the first term, which we call a, multiplied by 1 minus our common ratio r raised to the nth power. And all of this will be divided by 1 minus r. So like I mentioned, a is our first term in our geometric series. R is that common ratio. That's the number we multiply by to go from one term to the next. And n is the number of terms in our series. So let's use this information and this formula to be able to solve some different example problems. And in this first problem, the first term in a geometric series is 5. So they give us our a value. The common ratio is 2. So r is 2. And we need to find the sum of the first 10 terms in the series. So n is 10, since we have 10 terms that we're adding together. So let's make a little bit of space so that we can work this out. And before we just plug everything into the formula, let's get an idea of what this series looks like. So the first term we know is 5. Then to find the next term, we just multiply by the common ratio. So 5 times 2 is 10. Then the next term, 10 times 2 is 20. Then we have 40, and so on. We're going to do this 10 different times. If we want, we could even write out the last term. Since remember, the explicit formula, let's say for the 10th term in our geometric series, we can call it a sub 10 is equal to the first term, so a sub 1 multiplied by that common ratio, n minus 1 times. And of course, we're plugging in 10 here. So our first term, that's 5, multiplied by our common ratio, 2, raised to the 10 minus 1 power, or 2 to the 9th power, which is 512. So you can plug all this into a calculator to be able to find this very quickly. And what we would get is 2,560. So that is the last of the terms that we want to add together. Now, of course, you don't actually need to do all this. You don't need to find this last term, but it's good to remember these formulas when we discuss sequences in previous videos. So let's just use our information now to find the sum of this. We are finding the sum of the first 10 terms here in this geometric series. So using our formula, s sub 10, it's the first term, which is 5, multiplied by 1 minus our common ratio raised to the nth power, so 2 to the 10th power, all divided by 1 minus our common ratio, which is 2. So the denominator would be -1. So you get 5 divided by -1, which is just minus 5. And we have 1 minus 2 to the 10th. If you plug 2 to the 10th into the calculator, that's 1,024. So we get minus 5 times 1 minus this, which would be minus 1,023. And the negatives are going to cancel. We can multiply this together. We'd have 5,000 plus 5 times 23, and 5 times 23 would be 115. So this is 5,115, and that is what we put in our box here. So with that in mind, let's take a look at a couple different example problems. So for this problem, we need to find the sum of the first 7 terms in the following geometric series. So let's start by writing down our formula. We know that to find the sum of the first n terms, that it's equal to our starting term a multiplied by 1 minus our common ratio raised to the nth power, all divided by 1 minus our common ratio. And we just need to identify what a is. We can see our first term is 1,024. Our common ratio, we can see we're multiplying by a half to go from one term to the next. So r is 1/2, and they tell us that we're going to add up the first 7 terms. So n is equal to 7. And with all of that, let's just plug it into our formula. So to find the sum of the first 7 terms, this is equal to the first term multiplied by 1 minus the common ratio, 1/2, all raised to the nth power, or the 7th power. And this is all divided by 1 minus the common ratio of a half. So our denominator is just going to be a half. So you get 1024, and I'll put the divided by 1/2 on the outside. And we have multiplied by 1 minus 1 over 2 to the 7th. And 2 to the 7th is 128. So this is 1 over 128. And, well, we have a number divided by a fraction, which is the same as just multiplying by this fraction flipped. So 1024 divided by a half is really just 1024 multiplied by 2, which is 2048. And 1 minus this fraction, if we give this a common denominator, we can use 128. So 1 is really 128 over 128. So we subtract 1 in the numerator, so that's 127 over 128. And this you can plug into your calculator. And what you would get is 2032. So this would be your final sum. Now, if you really wanted, you could just figure out the next 4 terms here and then just add them on your calculator, since adding up 7 terms is not too bad. You can very simply do that with your calculator if you have the time. So that's a great way to check your work, but you can feel confident that this formula does indeed work.